Hello, welcome back. We're going to talk about lesson 4.2 today, and it's titled Using Intercepts. One of the greatest examples I've seen in this book is on the top of page 237. It says, who uses this? It's like you guys always say, when am I ever going to use this? Well, if you're lucky enough to ever learn how to dive, you understand some basics about physics. If you start to ascend or move up in the water column too quickly, things happen in your bloodstream. Bubbles start to form, and this is bad. It ends in the bends. So if you look at the top, page 237, you can see the safe ascent rate at which a diver should come up. We can use this all over the place, but today we're going to talk about two terms, y-intercept and x-intercept. I just want to take you quickly down to example 1. It says, find the x and y intercepts of the graph. Well, we're going to look at something like this. This is a little different than theirs. A y-intercept indicates we are intercepting the y-axis. So we would locate that here. If we had graph paper, we could see that that was about 3 units. And the thing about the y-intercept is x is always 0. We came to 0, the origin, and moved straight up. X is 0, y is 3. So we talk about the y-intercept when x equals 0. We also talk about the x-intercept, and that's when y equals 0. We didn't go up or down. We went left or right to the point on the x-axis. We could also call that 3. So the x-intercept is when y equals 0. The y-intercept is when x equals 0. And this point below would be 3, 0. The other way we can look at intercepts is when we have a function. Let's look at example 1, part B. It says we have, in standard form, the function 3x minus 2y equaling 12. Well, up here in this example, we see when x is 0, we can find the y-intercept. So the neat way to do this is to come down to the function and allow x to equal 0, and then we simply solve for y. Well, this term has canceled. It's disappeared. It became 0, and negative 2y equals 12. Of course, we're just going to divide both sides by negative 2. Y equals negative 6. When x equals 0. In turn, we're going to take the same equation, and when we're talking about an x-intercept, we remember the y value to be 0. So we're going to do the same thing here. 3x minus 2, we're going to allow y to equal 0 and solve that equation. We end up with 3x equals 12, x equals 4. That's a 4. When y equals 0. We have an x-intercept of 4 and a y-intercept of negative 6. Please try check it out problems at the bottom of page 237. Page 237, check it out 1A, B, and C. And complete those and come back to this recording and check the solutions. Let's first start with check it out problem 1A. You can see that they have this graph and they're asking find the x and y intercepts. Well, this is the simplest time that you'll find x and y intercepts. We simply locate the y and the x axis. So the y axis running vertically, we look to where the line intersects, and we can see it is at the point 0, 3. We would say y-intercept equals 3. Then we simply look over to the x-axis. We can see we're on the negative side of the origin there, and we can see that our x-intercept is 2. Let's look at 1b. 1b gives us this equation right here. And we remember that allowing y to equal 0, we would then find our x-intercept. So we get the equation negative 3x plus 5 times 0 equals 30. Negative 3x equals 30, dividing both sides by negative 3, x equals negative 10. And again, we would work with the y, allowing y to equal 0. X, negative 3 times 0 plus 5 times y equals 30. Pardon me cramming that in there. This term is removed, it becomes 0, and we get 5y equals 30, y is equal to 6. So our y-intercept and our x-intercepts are easily calculated as we allow those variables to take on the value 0. In 1c, 4 times 0 plus 2y equals 16. 2y equals 16. Y equals 8. For our y-intercept, we're going to allow x, again, we're going to allow y to equal 0 this time. So we have 4x plus 2 times 0 equal to 16. We get 4x equals 16, dividing both sides by 4. X equals 4 for an x-intercept of 4 and a y-intercept of 8. So let's go ahead and take a quick look at page 239. It says, remember to graph a linear function, you need to plot only 2 ordered pairs. Between any 2 points lies a straight line. It's often simplest to find ordered pairs that contain the intercepts. So 2a, we're starting with a function 2x minus 4y is equal to 8. If I need to graph this quickly, the fastest way is to take my 2 intercepts. And how do I do that? Well, I allow x to equal 0, and I solve for y. Negative 4y equals 8. Y equals negative 2 when x equals 0. And if I plot that point 0, negative 2, I've found my y-intercept. I do the same thing, and I allow y to equal 0. And I solve for x. 2x equals 8. X equals 4 when y equals 0. X equals 4 when y equals 0. Bent it a little bit there. That's okay. So that's the quickest way we can actually graph a linear function. I'd like you to check it out. I'd like you to do problems 3a and 3b below example 3. 3a and 3b come right back here, and we'll look at the solutions. The check it out problem 3a, it says use intercepts to graph the line described by each equation. We're going to go ahead and do that. We just are going to follow all of the nice examples set forward in example 3. We're going to take our x value, set it to 0, and solve for y. 4y equals negative 12, therefore y equals negative 3 when x equals 0. There's one of our points. We're going to solve for the second point, and we're going to allow y to equal 0. So negative 3x plus 4 times 0 is equal to negative 12. Negative 3x equals negative 12. X equals 4. Dividing both sides by negative 3. When y is 0, x is 4. And we do need to graph those. So let's plot each of those points. When x is 0, y is negative 3. That's our y-intercept. When y is 0, x is 4. That's our x-intercept. And we can quickly and painlessly, the best part, painlessly graph the equation. I want to take a quick look at part B. One of the things they suggest in example 3 is to put this in standard form. So that means we're going to gather all the terms on the left side. 1/3 x. That leaves me with -2 over here. And I get -1/3 x plus y equals -2. One of their suggestions to alleviate your frustration with fractions, we can take a value and multiply every single term by that number. If I were to take this function, multiply this side by 3, I'd have to do the same thing on this side, multiplying that by 3. I would get -x plus 3y equals -6. And we can see that's a much lovelier function to deal with. Now I'm going to go through my steps. Allowing x to equal 0, I get 3y equals -6. Y equals -2 when x is 0. Allowing y to equal 0, I get -x equals -6. X equals +6, dividing both sides by -1 when y is 0. And we could see, we could graph this on the same coordinate plane. Let's make it a different color. When x is 6, y is 0. There's our first point. And when x is 0, y is -2, our second point. So we could see that line with those two intercepts. Quick and easy. At the top of 238, you can see Madison Stewart. She's a Jefferson High School teacher. She says one of the ways that she teaches kids to solve by using intercepts is to use the cover-up method. First thing she would do, it's the same as allowing x to equal 0. The term basically disappears. So we end up with -3y equals 12 when x is 0. So y is equal to -4. I'm going to do the same thing with the y term. I'm going to take it up. Well, that's not a very good cover-up, is it? So 4x is equal to 12. 4x equals 12. So x equals 3. So I, even more quickly than before, I found my two intercepts. Y is -4. I'm going to plot that point. X is +3. I'm going to plot that point, and I simply connect the dots. Quick and easy graphing, painless. Don't know why kids hate graphing so much. It's so much fun. Anyway, your assignment is on PowerSchool. Please go there, and if you need help, please ask.